Hello everyone, I am Dr. Abha Kumari. Today we will discuss the reduction formula for the function 0 to infinity e to the power minus ax cos nx dx for the value a greater than 0. To solve this problem, let us first let in equals to 0 to infinity e to the power minus ax cos nx dx. Since this is a function of product of two functions, exponential and trigonometric, so here we use by parts. And we first let the first function as cos nx. So applying by parts, the integration we get cos nx integration e to the power minus ax dx 0 to infinity the whole limit, and then minus integration 0 to infinity n cos n minus 1x sin x e to the power minus ax divided by minus a into dx. Okay, now proceeding this value we have here, this is equals to what? Then we have getting the value as 1 by a. On integration what we get here, the cos nx e to the power minus ax divided by minus a from what? 0 to infinity. Fine. And then we have this value s. So n is taken the outside, and again we have the a, and this one is getting the plus sign. So 0 to infinity cos n minus 1x sin x e to the power minus ax into dx. Fine. So this is, now on substituting the value 0 and infinity, we are having here 1 by a. Fine. And then minus n by a. Now again we use this function as a product of two functions, again the trigonometric function and an exponential function. So again we use the by parts here. So applying by parts here, what we get as plus n by a is taken outside, then we have 0 to infinity cos n minus 1x sin x, fine, as the outside, and then we have e to the power minus ax into dx. Fine. Here we have the minus sign, so we left this minus sign here, so this function will becomes negative. So minus n by a. Fine. Now again we apply the by parts. So what we get here as 1 by a, then minus n by a. Fine. Cos n minus 1x into sin x. Again the integration of this function, we are having here minus a is divided by minus a. So it's a 0 to infinity, and then we have minus sign. Fine. And then 0 to infinity. Now d by dx of cos n minus 1x into sin x, and then integration of what? To 0 to infinity, integration of e to the power minus ax dx, and then whole dx. Fine. So on integration what we get here as 1 by a minus n by a. Here we are again getting the value 0. Then again we have here the minus n by a. Here is minus n by a. So minus n by a. Fine. And then we have integration. This is again we have minus by a, integration from 0 to infinity. Now differentiating this part, what we get here, this is u into v. So here we get cos n minus 1x into minus of, fine, cos x. And then we have here e to the power minus ax divided by minus a. And since it is a u into v, so the first part here we get, and then we have plus. So what we get the second part is plus cos n minus 1 cos n minus 2x. Fine. And then the differentiation of cos x is sin x into sin x e to the power minus ax divided by minus a, and then whole dx. Now after that, now in becomes in equals to 1 by a minus n by a square, then bracket we have 0 to infinity. So 0 to infinity e to the power minus ax, fine, and then cos nx dx minus n minus 1 cos n minus 2x, fine, and then sine square x, can have in the bracket sign, this one, and then dx, this way. So here we get this value. So this is equals to what? 1 by a minus n by a square, right? 0 to infinity e to the power minus ax cos nx. They are separating the value from here. So we are getting with this value minus n minus 1, 0 to infinity e to the power minus x. Now cos square n minus 2x, 1 minus cos square x, and then we have dx. What we have done, we just write the value of sin square x in terms of cos square x. Now this is equals to 1 by a minus n by a square, 0 to infinity e to the power minus ax cos nx dx minus n minus 1, 0 to infinity e to the power minus ax cos n minus 2x dx, fine. And again we have the value like this, and then again we have minus, here is minus, and then again we have minus sign, so plus n minus 1, 0 to infinity e to the power minus ax into cos nx dx, right? Now just multiplying the value from here, what we get, so this is 1 by a minus n by a square, 0 to infinity e to the power minus ax cos nx dx, fine. And now multiplying this value here, what we get is minus n minus 2, so n into n minus 1 divided by a square, 0 to infinity e to the power minus ax cos n minus 2x dx, and then we have the value plus n into n minus 1, fine, divided by a square, 0 to infinity e to the power minus ax cos nx dx, fine. But what we see here is that the value here we used, e to the power minus ax cos nx dx, is the given value which we have taken as let in equals to, like this, let in equals to this one. So we can write this value as in. So here we will write this thing as 1 by a minus n by a square in minus n into n minus 1 by a square in minus 2, and then plus we have n into n minus 1 divided by a square in, and on the left hand side we have in. So this gives the value as in equals to 1 by a minus, here we have, if we are taking the minus sign here, so what we get here is 1 by a square is in the common, so n, then we have in here, so this is plus n square and then minus n and then in minus n into n minus 1 divided by a square in minus 2. So this is equals to 1 by a minus 1 by a square, here is minus sign, so minus and minus being cancelled, so we are leaving with n square in, and then we have n into n minus 1 divided by a square in minus 2, fine. So by solving these two values, what we get here is, this implies in common, so 1 plus n square by a square in equals to 1 by a minus n into n minus 1 divided by a square in minus 2. Okay, so these are the values when we have expand the value for in, right? So we are looking for the value of what? In, fine. Therefore we will write it like in equals to, therefore in equals to, so what we will write here is, what we have here is in 1 plus n square by a square in. So here is in, na? So in bracket, what we have 1 plus n square by a square, and this value is equals to 1 by a minus n into n minus 1 divided by a square in minus 2, right? So this implies in into a square plus n square divided by a square, this value is equals to 1 by a, and then we have, sorry, here is the plus sign because we have here the minus 1 by a square common, and we have the minus within the bracket, so we are getting here the plus sign. So this is your plus n into n minus 1 divided by a square in minus 2, fine. And this will give the value of in as, so we'll write here the in is equals to a divided by a square plus n square, and then plus n into n minus 1 divided by n square plus a square in minus 2, right? Therefore, the value here we get for the reduction formula is therefore 0 to infinity e to the power minus ax cos nx dx. So we are looking here for the value of cos nx, and then we have dx. This one, cos e to the power minus ax cos nx dx, right? So we'll write here is cos nx dx is equals to a by a square plus n square, fine, and then plus n into n minus 1 divided by n square plus a square in minus 2. This is the reduction formula for the cos function. So next is reduction formula for the infinity to the power minus ax into sine nx dx. So do it yourself. Thank you.